We're going to look at how information, data, and research is collected. So a population is a group of people or objects that you want to collect information about, maybe like the entire population of the United States. A sample is a smaller group selected from your population, because usually you can't survey every person in the United States, so you survey a smaller group instead and use that as an estimation. So let's determine what our sample and population is here. So a phone company wants to collect information on internet access in the US. It surveys 1,200 households and finds some stuff out. So we want our population. They wanted information on internet access in the United States. So our population is all people or all households in the United States. Our goal was to collect information from that group. The sample is the set that you actually surveyed and got information from. So they surveyed 1,200 households, not everybody in the United States, but they surveyed 1,200 households, so that is our sample. So your population is the whole group you want info about. The sample is, hey, who did I actually ask? There are different kinds of samples, and some of them are more accurate for estimating your population than others. A self-selected or voluntary response sample is just like people who volunteer to be part of the sample, like on American Idol or those other shows, The Voice. If you call in your vote, you are choosing to be part of that sample by volunteering who you think is the best. They're not the most accurate. A systematic sample is better. It uses some kind of rule to select like every 10th person in the phone book. A convenience sample is just a sample created from members who it's easy to get information about. Maybe like you ask your friends what their favorite color is and use that for your data. Not accurate, but it's done, unfortunately. A random sample is the best and most accurate kind of sample to represent your population. So something like drawing 5 names of people out of a hat, or a computer generates a random set of people. So this reporter wants to survey members about whether they prefer cats or dogs. So if you mail out a survey and use only those that are returned, that's a self-selected sample. Only those who are choosing to volunteer their information and get it mailed back actually are a part of your sample. If you're going through and calling every 15th person in the phone book, you have some method to your sampling. That's a systematic sample. And if you just ask your coworkers at the station, that's a convenience sample because you just got information from people that was easy to get it from. If you use a computer program to generate 50 random viewers, it says random, that's a random sample. So like I said, some of those samples are better than others. An unbiased sample is one that accurately represents your population. A biased sample is bad, biased for bad. It over or underrepresents some part of your population. So let's decide if these are biased or unbiased. So a restaurant manager asks how often high school students go out to eat. So if he makes a list, generates a random set of students and surveys them, that should be unbiased because it's a random sample, which is something that should be a fairly accurate representation of your population. If the manager just asks the next 50 students that come into the restaurant how often they eat, that's going to be a biased sample. It won't accurately represent everyone. First off, it's a convenience sample, just selected people who were easy to access for data. And he's asking people that are in the restaurant. So if you're surveying people about going out to eat and you only ask people who are already out eating, you're probably going to get a higher result of, hey, I eat out like 4 times a week, than if you also included people who are not currently out eating, like people who are at home. So this is probably going to overestimate the result of how often people go out to eat. Things that you can also do to increase your accuracy are to increase your sample size. So your sample size is how many data values you have in your sample. The larger your sample, the more accurate it's going to represent your population. How different it could be from your true population result is called your margin of error. If the true percentage of people in the United States who own a cat is like 20%, and in your sample you got that 25% of people own a cat, your margin of error is 5% because you were 5% off the true value from your population. So how you calculate that comes from that formula right there. The max margin of error you could have is 1 over the square root of the sample size. So larger sample size will give you a smaller margin of error. Survey asked 5,000 people what kind of phone they own and got those results. We want the margin of error for our survey. So ME is kind of your abbreviation for margin of error. It's 1 over the square root of your sample size. So N, since we asked 5,000 people, is 5,000. If we just plug that in there, we got plus or minus 1 over the square root of 5,000. And if you punch it into a calculator, you should get approximately positive and negative 0.0141. We usually do like 4 decimal places because we turn it into a percent and then it's 1.41%. Either too high or too low is the max result difference you could get between your true population value. Let's use that and our sample data to give an interval that's likely to contain the true percentage of the population that owns an iPhone. So if you look at our data, we got 30% said they owned an iPhone in our sample. Our margin of error is 1.41%. So if we take that 30% from our sample and add and subtract the margin of error from it, we'll get like a minimum percentage of the entire population that we'd expect to own an iPhone and a maximum percentage of the entire population that we'd expect to own an iPhone. So if you add and subtract your 1.41%, you'd expect the entire population of the United States, 28.59 to 31.41% of them to own an iPhone. Your sample said 30. Hey, that using our margin of error gives us our population expectation. So if we make our sample size bigger, our margin of error is going to get smaller if we survey 10,000 people instead of 5,000. If you want to know by how much, you could actually calculate it. That would give us a 1% margin of error instead of a 1.41% margin of error. Let's go backwards. So school system wants to survey students on their favorite lunch, and they want to be accurate to within a 10% margin of error. How many students do they need to survey? We're trying to find N, so let's plug in our margin of error to our formula and solve for N. So 10%, I'm going to change it back to a decimal. You'd have 0.1 equals plus or minus 1 over the square root of N. We need to get square root of N out of the denominator, so multiply by it on both sides. And then if you're trying to get N by itself, we need to divide by 1/10 or multiply by 10. So you'd have the square root of N would equal plus or minus 10. Now if I square both sides to undo my square root, well, if I square something, it's going to become positive, which makes sense because it should be a positive number of people.